The sections we're going to be looking at today are sections 15 and 16. Sections 15 and 16 are going to relate to functions, domain, range, and how to write this information in what is called interval notation. Okay, so a function, okay, let's start with the term relation first. We'll start with relation as our first term. A relation is a set of ordered pairs with starting values called inputs. The inputs are, in essence, the x values, paired with a set of ending values that are called the outputs. The outputs, in other words, are the y values. The domain itself is what we call the x values of these. And the x values can also be called, as we said here, the inputs. The range are the y values, or what we call the outputs. A function is a special relation in which each x value corresponds to exactly one y value. Okay, so for every x, there is only one y answer in order for it to be a function. If an x value has two or more y values or outputs, it is not a function. So if you have a set of data, if I gave you, let's say, these ordered pairs, let's say I gave you 3, 7, 2, -1, and 3, 5. If I were to ask you what is the domain would be the x values. So we would name the 3, the 2. We would not write 3 again because I already have 3 one time and that would be redundant. If I'm asked to identify the range, I would give the y values, the 7, the -1, the 5. If I'm asked, is this a function, what you need to pay attention to is the fact that this 3 here and here has two different answers. So if one x has two or more answers, no, that is not a function. If there is only one matching pair with each, then it would be. Another thing that we are going to look at is something called the vertical line test to determine if something is a function. Vertical line test to determine if the graph is a function. In other words, if you hold your pencil vertically over the graph, okay, so here's your pencil. You're gonna hold your pencil vertically. If it crosses only once, one time, then we'd say yes, it is a function. If it crosses two or more times, no, it is not a function. So let me give you an example of this. So if we have, let me draw a couple of, let me just do a couple of graphs up here, and then I'll draw images on them and we'll determine with the vertical line test if they are or are not. Okay, so let's say we have this, this, all right. So if I were to, let's say, and I'll just use a red line, if this is, and I'll put a little arrow at the top, if this is my pencil, it would only ever cross, if I slid it up or if I slid it down to the left or the right, it's only ever going to cross at one point. So for this first one, we would say, yes, it's a function. If I held my pen here vertically, here you would see it, like I said, here was one time. Here it would cross one, two times. Since it crosses twice, no, it is not a function. If I had a pen held up here, it would cross at 1, 2, 3, 4, 5, 6 places. So no, this one is not a function. If I have one drawn here, it's only going to cross once. So yes, it's a function. And wherever I might have this one, it's only ever going to cross, if it's being held vertically, it's only still going to cross one time. So yes, this one's a function. And here, no matter where I draw it, it's still only going to cross at one place at any location you would move it to. So yes, this one would also be considered a function. So the vertical line test allows you just to hold your pen to see if it is going to be a function or not. Now, how do we use function notation? If we are given an equation and we are asked to plug in a value, we can solve for those equations. So let's say I'm going to give you the equation. Okay, let's say we have f of x equals x squared minus 3x plus 5. That will be written in the form of a function. I want to solve for f of 0, and I also want to solve for f of negative 2. What I'm going to do is I'm going to plug in the value I have here. So if I plug in a 0 for x, that will be 0 squared minus 3 times 0 plus 5. So this is nothing, plus 5. So my solution, when I plug in 0, f of 0 is going to give me an answer of positive 5. I could actually write this as an ordered pair because this is my x value. The number 5 technically is my y value. If you remember previously, and let me put this here, when we were working with y equals mx plus b, this f of x piece, this technically means y equals. So that's why we're saying y is equal to 5, and the x, the 0, is in the place where the x goes. The answer on the other side of the equals is our solution. Let's do the same thing here. Now, since I'm using -2, it's going to be in a parenthesis when I square it. Wait a minute. Okay, so as we solve this, -2 squared would give me a positive 4. -3 times -2 gives me a positive 6, and then plus 5. So f of -2, 4 and 6 is 10. 10 plus 5 gives me 15. If I want to write this as an ordered pair, my x is -2, my y is 15. Because remember, this means y equals. So y is equal to 15. So you may have situations where you're going to be asked to plug in a value for x to solve and then get a solution for y. When we are looking at using interval notation, that is a standard or a way to write our solutions. Interval notation. It's a way we can write the domain and the range. If we have a solid circle, if something is equal to, if it is included, we're going to use square brackets to represent those. If we have an open circle, if something is not included, for example, things that would not be included would be negative infinity, positive infinity. So for interval notation for those items, we would use parentheses. Infinity means something goes on forever in the positive direction. Negative infinity goes on forever in the left, negative direction. There is one other thing that we might see, which is called a union sign. We would use the letter, it looks like a big U. It is the union sign is used to join two parts as one answer. Sometimes there may be a gap, a break in the graph that you're looking at, which would allow that you might need to have to use that union sign. Okay, so let me give you a graph here. I'm going to do two graphs, one here and one here. Okay, so for the circle that I have, if I'm identifying the domain are my x values. X values are read from left to right. So as I look here, I'm looking for my leftmost point. -1, -2, -3. My leftmost point is -3. It includes it, so I would use a square bracket and I would write -3. Then I'm going to go to the right. 1, 2, 3, 4. The furthest point to the right is at a +4. It includes it, so I would use a square bracket. That would be my domain. For this problem, if I'm looking for the range are the y values, and we look at these from bottom to top because it's always small to large. So we're going to start at this bottom point. So let's count. -1, 2, 3, 4, 5. The bottom point is at -5. The upper point is at 1, 2, 3, at a +3. And we would use square brackets with both of those. Domain and range are always small to large. So domain is read left to right, range is read bottom to top. Okay. Let's say we have this. Okay. All right, so for this one, let's change our colors here. Okay, my domain is left to right. So as I go to the arrow, I'm going to notice this arrow means it's going to keep going on and on forever. If something keeps going left forever, that's going to be negative infinity. For the domain going to the right, as you see, this line here is going to continue on and on and on. So as you continue to the right, that is positive infinity. And we always use parentheses with the infinity, left to right. Now, when we look at the range we said is bottom to top. So we want to come to the graph and go to the lowest point, which is here. The lowest point is at what value? I'm going to slide to the left. It's at -2. So the bottommost point is at -2. It includes it, so I put a squared bracket. And then it's going to go up this way, up that way. Whichever way, it's still going up. Up in this direction is positive infinity. Down here to the bottom would have been a negative, no, not a -8, excuse me, negative infinity. So since that's going upward, the right value is a positive infinity, and we use a parenthesis with that. So as you're doing interval notation and you're writing, identifying the domain and the range, that's how we're going to look at those. Let's see. You may also, sometimes instead of a graph such as this, you could potentially have a graph that could look such as, let me give you one. Let's do a straight line graph. Okay, let's say we have a graph in this format. So if we have a graph of this nature, we would have, let's say, if I had something such as this, and then my graph is going in this direction. The other thing is it could possibly have a solid dot on it. That could also possibly be what we may have on that graph. Sometimes the interval notation symbols are used on the graph, and sometimes they may not be. So if for this, if I'm writing, and all I can do here is write my domain, it would be +1 to infinity. As I also said, it could have been a solid circle here, and it could have been drawn to the right. Okay, let's say we have an open circle that is here, and then it's going to be in this direction. Okay, now since it's going to go off the page in this direction, that's going to be negative infinity. So the domain, the first thing that I list is the smallest, which is the negative infinity. Then it's going to move up to 1, 2, 3. That is located at 3. It's an open circle where the 3 is. So in this scenario, I would have to use a parenthesis that looks like that. If it were graphed this way, it could be that there was a parenthesis here and the line could have been drawn going in this direction. And that's all that we're looking at as we are working here in sections 15 and 16 is domain and range, identifying those. Is something a function using the vertical line test, or by looking at how many points you have, and every x can only have one y value. And then writing those domains and ranges in interval notation.